All right, last video. Let's knock this out. So given, again, you guys are spoiled rotten. Look at all this information it gave us. Wow. Gave us that these sides were all congruent, that these are right angles. Wow, neat, so cool. All right, so given. Being lazy, just making an arrow. All right, so sometimes it might tell you to say, well, since these are triangles and they specifically have right angles, it might make you say triangle Max and triangle Jeff are right triangles by definition. Why is this important? Well, since this is a right triangle, that's a piece of information. Well, notice that MX and JF, what's so great about those? Well, they're hypotenuses. All right, they're the longest side of a right triangle. They're opposite the right angle. They're hypotenuses. And then MA and JE are legs. All right, so these two triangles are congruent by hypotenuse leg. I'll write this one out just in case you forgot. Hypotenuse leg. So remember, you need to have a right triangle. The hypotenuses have to be congruent, and a leg has to be congruent. That's how you use hypotenuse leg. Then from here, we're in very good shape, because now I can pick off anything I haven't said is congruent. Specifically, let's do X and F. Those two angles are congruent because they're corresponding parts of congruent triangles. Thus, they are congruent. CPCTC. All right. Whew. Two more. We can do it, I believe. All right. FH and IS are congruent. Furthermore, they are parallel. Not all the time, but the overwhelming majority of the time, over 99% of the time, when you see parallel lines, you need to think about alternate interior angles. Chances are we're going to be using that. Chances, not guaranteed, but most likely. Let's be a little lazy. All right, now let's focus on things. HFS. HFS and ISF. These two angles. Why are these two angles congruent? Well, let's extend stuff. All right, we got these parallel lines. FH and IS are parallel. This is a transversal. All right, OMG. There we go. They're alternate interior angles. All right, alternate interior angles. Parentheses AIA. All right. So what do we do from here? Well, there's a couple things like, no, there's not really. Just now realized we have this shared side. I did a horrible job, but we're just going to live with it. FS is congruent to FS by reflexive. And something I forgot to mention, this spells out fish. Isn't that funny? Fish. All right, so we have a side, an angle, a side. So I can specifically say these triangles are congruent. So I'm going to say H. FS is a triangle. What corresponds to H? I corresponds to H. What corresponds to F? S, and then S, F. All right, by SAS. And then the end, bloop, angle H is congruent to angle I. CPCTC. Corresponding parts of congruent triangles are congruent. Then last proof of the day. OM bisects angle LMN. So this is an angle bisector. OM is bisecting this right here. If I can draw. My stylus wasn't working for a second. All right, so I know that angle and that angle are going to be congruent. Then it's telling me these two angles are congruent. Boop. All right, but anyways, before I get too excited, let's actually just start writing this out, being a little lazy. Given definition of angle bisector, this is what I was talking about first, is that this angle is being bisected. So remember, an angle bisector, when an angle is being bisected, it creates two congruent angles. So LMO and angle NMO. And remember, reading an angle tells the story, it tells the path. You start at L, go to M, end at O. Similarly, NMO. All right. Definition of angle bisector, this shared side, a lot of chaos going on right now, but this shared side is congruent to itself. MO is congruent to MO by the reflexive property. All right, so now I can say that the two triangles are congruent. I can say triangle LMO is congruent to triangle NMO. But why? Well, I have an angle, I have a side, I have an angle. So angle, side, angle. And the last step and reason of these guided notes always end with what we're trying to prove. ML is congruent to MN. Why? Corresponding parts of congruent triangles are congruent in CPCTC. All right, make sure we knock out these Canvas problems. I hope you had a lot of